Hey guys, you'll just fill this in as you watch it. It's going to be your test review that we normally do. Your test will be on Thursday and Friday, so this video will cover the part that's on Thursday. The part that's on Friday we'll do in class on Friday. So I'm going to give you actually 10 points for what you do today, and they are all from completing what I do in this video. So on your test on Thursday, you're going to be asked to do a lot of the graphing part of this chapter. Whoops, sorry. A lot of the graphing. The equations are going to be in two forms, and you can see them right here. This right here is called vertex form. You don't really need to know that, but you do need to know that it's super easy for you to find the vertex when it's in vertex form. So remember how we do that. The vertex is at whatever makes this 0 or the opposite of what you'd think it would be. So at -3, comma, and then exactly what you would think it would be. So this has a vertex at -3, -5. We know that the domain is all reals all the time. These, though, are the kind where you have to make a table of values. So when it's in vertex form, before you go graph it, you have to make a table of values, and what you put in for x is the same every time. You put in -2, -1, 0, 1, and 2. Then for the y, you go square those, and it'll be the same every time. 4, 1, 0, 1 times 1, and 2 times 2. Your third column comes from multiplying all those y's by whatever number's out front. If it's just a negative, you just multiply them all by -1. This one's a 2, so I'm going to double all of these. 4 times 2, 1 times 2, 0 times 2, 1 times 2, and 4 times 2. Notice the symmetry here, 8, 8, 2, 2, and a 0. Then what you do is you go plot all the points x, comma, new y. So you go to -2, 8, put a dot, check. You go to -1, 2, you put a dot, check. You go to 0, 0, you put a dot, check. You go to 1, 2, and then you go to 2, 8, and you make this nice parabola. And it's this one that you're going to slide. You can now answer this question if you want. We know that that's going to be a minimum. To get our new parabola, or our answer parabola, we slide 3 to the left and 5 down. So every point up here, I'm going to go 1, 2, 3 to the left, and 1, 2, 3, 4, 5 down. So I'm going to take every point and move it 3 to the left and 5 down. 1, 2, 3 to the left, 1, 2, 3, 4, 5 down. 1, 2, 3 to the left, 1, 2, 3, 4, 5 down. Sometimes then you can start using some symmetry to help you out. This right here in red is the answer parabola. So on the kind that are in vertex form, you should have two parabolas. The blue one that comes from making the table, and the red one that comes from sliding it around. Remember, our axis of symmetry, I always write x equals, and it's the x coordinate of the vertex. Our range is y is, and it's either less than or equal to or greater than or equal to. On this red line, red parabola right here, my curve or my parabola is living above that line. So it's y greater than or equal to -5. The axis of symmetry comes from the x. The range comes or is controlled by the y. So that one's done. You'll have to do one just like it on your test. For number 2, this is not in vertex form. This is in what's called standard form. So you're going to have to monitor and adjust here because you don't know the vertex just by looking at this form. These you don't have to make the table. You can just go ahead and start by finding the x coordinate of the vertex. There's a formula for that. We do the opposite of the b term over 2 times the a term. So in this case, I'll do the opposite of 4 over 2 times -2. And I get -4 over -4. and that gives me a vertex of 1. That also gives me my axis of symmetry, would be at x equals 1. I don't know my domain is always all reals. So really all I need to do is go get that y coordinate of the vertex. And to do that, I do a plug and chug. I take this x, and I go to my calculator, and I plug it in right here. I use parentheses, so you should take out your calculators, pause the video, and go get one if you don't have one. There's no point in just taking my, again, these are to review you for the test, and you guys have been doing awesome on the test, and I think it's because you're always incredibly engaged in the review. Makes me a little worried that I'm doing this on video, that some of you are just going to kind of not listen or just write it down, and it's been working really well for you for the test. So go hit a pause and go grab a calculator. On that calculator, we're going to do -2, then do parentheses, 1 squared. Again, I'm putting a 1 in right here, plus 4, use parentheses, times 1, plus 5. Go hit enter, and it should tell you that the answer is 7. So I put a 7 right here, and I go graph that. I've got 1, 7. Now you do have your graphing calculator, so sometimes what's kind of nice too is to go enter this in the y equals on your calculator. So like in the top left, there's the y equals. If you enter that and hit graph, you'll be able to see what it looks like. But let this help you too. This is going to open down. So I kind of know it's going to kind of go like this and like this. But you can go ahead and hit the graph on your graphing calculator. She allowed that. So make sure you go to your y equals on your graphing calculator and enter y equals. Make sure you do a negative and not a subtraction for that. So again, pause the video so you can go see it. My range, again, is controlled by that y coordinate of the vertex. And you can see up here, once I've graphed it, my y's are all under that. So I'd say y less than or equal to 7. And that's a max. I don't think I answered that question. So those are the two kinds that you're going to need to know how to graph when they're in the different forms. So I would challenge you to go try this one, but I'm not going to do it. This is in vertex form, so this would be done like number 1. But if you think you need some practice on that, maybe I'll come back. I have to see how long this video will take. I'd also challenge you to go try number 4. I might go back to them though. We'll see. I'm going to do 15 minutes of video notes. If I have time, I'll go back to those. Next step, without graphing, can you name the vertex, the axis of symmetry, max or min, domain and range, and all the transformations? So again, the axis of symmetry comes from x equals the x coordinate of the vertex. We want to say -3, but remember it's the opposite of what you would think. The vertex, because this is in vertex form, would be at 3, exactly what I think. Is it a min or a max? Think positive makes me smile. Think negative makes me frown. And then go look at the sign of this lead number. That's what determines it. Because that's a positive 1/2, I will be smiling and I will have a min. The domain is all reals all the time. My range, again, is controlled by the y coordinate right here of the vertex. So don't just put 7 down. I need to. If I had to guess, I'd guess between this or this. But remember, we've decided that this is a min, which means I will live above that line. So y greater than or equal to 7. Now here's a thought for you. Because you're allowed to use your calculators, you might want to go enter that in your y equals button to see if it looks good. And I'll bring up my calculator in a minute here if I have time. Again, I want to keep this video at 15 minutes, so I'm making sure I hit one of everything. And then if I have some time, we'll go back. What are the transformations? You have to tell me what every single one of these numbers does in detail. What does that have to? It'd be a vertical compression. Remember, if something bigger than 1, it'll be a stretch. But if I squish you down to half of your height, you'd get compressed. That's you right there. Vertical compression of 1/2. I think you guys told me you have to write that. You're going to go 3 to the right. And then 7 up. Had there been a negative, then you'd write x-axis reflection. Like on this one, number 6, x-axis reflection, vertical stretch of 4, 2 to the left, the opposite of what I would think, and then 5 up, exactly what I think. All right, last one up here. A submarine makes its descent and rise according to a parabolic motion. All that means is it goes down and then it comes back up. Maybe here's the water level. It starts submerged at 10 feet, and its depth d can be modeled with this equation. So that gives you the depth. After how many seconds does it reach its lowest depth? These are always about the vertex. I need to figure out, if I were to graph that submarine, when did it reach its lowest depth? That's the vertex. And to do that, I do negative b over twice a. So I do negative 900. That's why I like to think of this negative as the opposite of b. Here's b. The opposite would be positive 900. So the opposite of b over 2 times a. You'd go to your calculator and do 900 divided by 16. And I need to grab a calculator here. And you should also grab one. 900 divided by 16 is equal to 56.25. How many seconds? So I'll abbreviate that, seconds. Until it reaches. So if I were graphing this, and this was now instead of x, it's time, I would have gone right here to 56.25, and that's when it bottoms out. How low did it get? That's its depth, and it says in the equation that the depth is equal to 8 times time squared. Again, we're just putting this guy in for the t, minus 900 times the time, and then minus 10. So you just go to your calculator and enter that. Actually, I'm going to have you guys enter it. That'll be one of the things that'll help me know if you actually listen to these notes. So you pause the video and you go ahead and, just a second, you go ahead and enter that on your calculator. Its answer will be labeled in feet below the surface. So whatever you get, feet. So pause the video and go fill that in. Next, after how long will the submarine return to a depth of 10 feet? So this is the scenario. It was at 10, took 56.25 seconds to drop to its lowest point, and that will be whatever you got for part B, and then it went symmetrically back up. So all you need to do for that last question is double your x-coordinate. You know this was 56.25, and that will be as well. So you just do 56.25 times 2, which will give you 112.5 seconds. So the first part of your test that's going to take place on Thursday will be all about this graphing. And I do have a little time left, so I'm going to go back and talk about actually this one before I finish. So at number 4, this is not in vertex form. I have no clue what the vertex is until I do a little work. My work is to start right away and say x is the opposite of b over 2 times the a. I go over here to b, and I take the opposite. So I do a 6 over 2 times. I don't see the a, which means there is a 1 right there. 6 divided by 2 is 3. So the x-coordinate of the vertex is 3. That gives me my axis of symmetry. I also know this. I also know because this is positive, it makes a smile, which means I'll be at a minimum. And then I'm going to show you how to go check everything on your calculator, even right down to the vertex if you want. But let's go get the y-coordinate of the vertex. You should take and do the x right here squared minus 6 times the x plus 1. And you go enter that in your calculator and use parentheses just in case they're negative. Sometimes we get goofed up. So make sure you use parentheses when you're putting that in. And I get a negative 8. And because it is a minimum, I know y is always greater than or equal to -8. Now, before I quit the video, take out your calculators and let's go show you how to enter down there. I thought I still had my calculator loaded from calculus, but I guess I don't. So just wait a second while you maybe go grab a calculator or turn it on. Let's go take a look here. I'm going to get this out of the way. All right, so you can see I was doing a lot of stuff on my calculator in my other class. So I'm going to go to the y equals. I'm going to clear all my calculus stuff out of here. And let's go work with the one you guys should be working with. We were just doing this one at the top of the page, x squared minus 6x plus 1. Let's go see what that looks like. X squared minus 6x plus 1. Let's go see if we did it right, and let's go see what the graph looks like. So I'm going to go hit, actually, I messed with my window in calculus, so I always hit zoom 6, which sets it in a 10 by 10 grid. Take a look. It looks pretty darn good. If you can see here, this vertex is 3 to the right, and we got 3, and it's 8 down. So I'm very confident in the answer for my vertex. I can see that it's a minimum. I can see that the y's are all greater than or equal to -8, and it also will help me graph it because you can see when I go graph it, I'll just plot that vertex and I'll go right here almost to 6 and put a dot, and right in front of 0 and put a dot. And that'll really help me graph it on my test because I've got the 3, -8 right here, and then I said I'll go right before the 6 and put a dot, and right before the 0 and put a dot. And I can just let my calculator do the work with the graphing. So that's it. Have a good one. I'll be back tomorrow.